Did you know the secret to some of the laser light shows is a computer-controlled mirror that splits or aims the beam up into the sky or onto a screen? Check out our homemade laser light show reflector. The laser shines onto the mirror that reflects the beam out onto our screen, and you see the bright green dot. Did you notice, though, that the mirror is glued to a rubber membrane? That's so I can control the mirror's movement instead of a computer. So predict what you think will happen to that green dot when I make that membrane move by 1, tapping on it, 2, speaking into it, or 3, touching it with a speaker while we play some music. Talk it over with a classmate and make your predictions. Ready?
Science! She blinded me with science!
Excuse me here for a sec, but here's the cool part.
So what's going on? Well, we know the laser reflects off the mirror as a single dot, right? As the mirror moves, so does the dot. Our eyes try to keep pace, but they can't catch every split-second change. So our brains blur the boundaries between each movement, creating a mesmerizing line that traces out all sorts of unique patterns. It's called persistence of vision. It's like watching a smooth dance rather than a series of snapshots. And it's how motion pictures, including crash test videos, work. Your brain and eyes blend together a series of individual pictures or frames that are shown sequentially, very quickly, usually around 30 frames per second. The result is the optical illusion of motion. Now let's get back to mirrors and lasers and look at one way they can make cars safer.
LiDAR is short for light detection and ranging, and lasers and mirrors are at the heart of LiDAR systems and vehicles. In fact, some LiDAR systems use rotating mirrors, just like our homemade reflector, to disperse the laser light to detect vehicles and obstacles. But all LiDAR systems, like this one, send out pulses of invisible laser light that reflect off surrounding objects and return to the sensor. The sensors use the return time of each pulse to calculate the distance to the objects. Repeating this process millions of times per second creates a real-time 3D map of the environment called a point cloud. Look, that sensor is capturing everything around me. The car, my buddy Ralph here, even the camera crew.
A car's computer can use the LiDAR point cloud and similar technologies for vehicle automation and obstacle detection. Detecting obstacles is an important part of the crash avoidance research that's done at the VRC.